Welcome to our very first deep dive, and we're kicking things off by diving into the world of material science.
It's going to be a fascinating journey.
It really is. And today, we're going to explore something that's pretty much as close as we can get to real-life superpowers. Carbon fiber.
It really does feel like something out of a comic book.
Right. I mean, you've probably heard of it. It's known for being incredibly strong,
Oh, yeah.
but also amazingly light.
That combination is really what makes it special.
It is. And that's why it's so sought after in so many different fields, from airplanes and race cars
Of course.
to even tennis rackets and heated clothing.
You find it everywhere. It's pretty amazing.
It really is. Now, I've always found it fascinating how carbon fiber can seem to defy logic.
How so?
Well, think about the graphite in your pencil.
Okay.
It's made of carbon atoms, just like carbon fiber.
Right.
But while graphite is soft and smudges easily, carbon fiber can be molded into structures that are stronger than steel.
It's true. It's all about the arrangement of those carbon atoms.
So it's the same basic ingredient, but a totally different outcome.
Yeah, think of graphite like a stack of sheets of paper. Each sheet is strong on its own,
Okay.
but the layers can easily slide against each other.
Which is why it's so soft.
Exactly. But with carbon fiber, those carbon atoms are bonded together in long, thin chains, like super tiny threads.
I see.
And they're all bunched together and aligned in the same direction.
So it's like weaving together countless tiny threads.
You got it. And that's what gives carbon fiber its incredible strength along the length of the fiber.
Okay, that makes sense. But how do we actually compare carbon fiber strength to other materials we're more familiar with?
Well, a good way to do that is to look at something called tensile strength.
Which is?
It's basically a measure of how much pulling force a material can withstand before breaking.
Okay, I'm following.
So carbon fiber has a tensile strength of around 4,000 megapascals.
4,000. Got it.
To put that in perspective, high-strength steel can range from 400 to 1,500 megapascals.
Okay, so quite a bit lower.
And aluminum alloys typically fall between 200 and 550 megapascals.
Wow, that's a huge difference.
It is. We're talking about a material that's significantly stronger than both steel and aluminum.
That's impressive. But we also mentioned that carbon fiber is incredibly light. How does its weight compare?
Well, to understand that, we need to look at density.
Which is basically how much mass is packed into a given volume.
You got it. So carbon fiber comes in at around 1.75 grams per cubic centimeter.
Okay.
Steel, on the other hand, has a density of about 7.85 grams per cubic centimeter.
So more than 4 times denser.
Exactly. And aluminum sits at 2.70.
Okay, so carbon fiber is significantly lighter than both of them.
It is.
So, to recap, we've got a material that's both incredibly strong and incredibly light.
And that's what we call a high strength-to-weight ratio.
And that's one of the key reasons why it's used in fields like aerospace, automotive engineering, and even sports equipment.
Exactly. You want your airplanes and race cars to be as light as possible.
To improve fuel efficiency and speed.
Right. But they also need to be strong enough to withstand incredible forces. And that's where carbon fiber really shines.
I can definitely see why it's so sought after. But I have to admit, I'm still trying to fully grasp what this high strength-to-weight ratio actually means in real-world terms.
I get that. It's one thing to talk about numbers, but another to really visualize it.
Exactly.
So imagine you have 3 blocks of material, all the same size.
Okay.
One made of carbon fiber, one steel, and one aluminum.
Got it.
If you tried to lift each block, you'd be amazed at the difference.
Oh, so?
The carbon fiber block would feel incredibly light, almost effortless to pick up.
Wow, really?
The steel block would be much heavier, requiring a lot more effort, and the aluminum block would fall somewhere in between.
That's a great way to picture it. And it makes sense why they'd want to use carbon fiber for things like airplanes. Less weight means less fuel needed to get them off the ground.
Exactly. And it's not just about fuel efficiency. Layer materials also mean faster acceleration and better handling.
Which is why carbon fiber is so popular in high-performance cars and racing bikes.
Precisely.
Well, this high strength-to-weight ratio is clearly a game changer.
You could say that.
But it makes me wonder, if it's so amazing, why isn't everything made of carbon fiber?
That's a great question, and it brings us to one of the major limitations of carbon fiber: cost.
Ah, so it's not all sunshine and rainbows then.
Not quite. It's significantly more expensive to produce than traditional materials like steel or aluminum.
I see.
The manufacturing process involves high temperatures, specialized equipment, and multiple steps, which all contribute to that higher cost.
So it's kind of like the caviar of the material world.
You could say that, and that's why you mostly see it used in those high-performance applications where the benefits justify the cost.
That makes sense.
But there is a lot of research going on to try to find ways to produce it more efficiently and affordably.
So there's hope for the future.
Oh, absolutely. If those efforts are successful, we could start to see carbon fiber used in a much wider range of everyday applications.
That would be incredible. Imagine cars, bikes, even buildings made lighter, stronger, and more efficient thanks to carbon fiber.
It's a fascinating thought, and we're only just beginning to scratch the surface of what's possible.
Well, we've talked about strength and weight, but I know carbon fiber has some other pretty amazing properties too.
It does. Carbon fiber is full of surprises.
I bet it is.
It's an excellent thermal insulator, meaning it doesn't transfer heat very easily.
Oh, interesting.
And it also has a near zero coefficient of thermal expansion.
Okay, I'm going to need you to break those down for me. Those sound a little technical.
Fair enough. Let's start with thermal conductivity.
Okay.
It basically describes how easily a material lets heat pass through it.
Okay, so a low thermal conductivity means it acts like a barrier to heat.
Precisely. So, for example, a carbon fiber bicycle frame wouldn't get scorching hot sitting out in the sun.
And it wouldn't feel freezing cold to the touch on a chilly morning.
Right. It stays relatively temperature neutral. And as for thermal expansion, well, that just means that carbon fiber doesn't change size much when it gets hot or cold.
Unlike metals, which expand when heated and contract when cooled.
Exactly.
So you're saying a carbon fiber structure would hold its shape better even under extreme temperatures.
Precisely. That's why it's so valuable for things like aerospace components or scientific instruments.
I can see that.
Imagine a telescope mirror made from carbon fiber.
Okay.
It wouldn't warp or distort due to temperature changes, so you could get incredibly accurate observations.
That's amazing.
Yeah.
Carbon fiber really is a remarkable material.
It is.
But I have to admit, I'm still a bit mystified by how it's actually made.
It is a fairly complex process, but I can give you a simplified version.
Perfect.
It all starts with special fibers, mostly a material called PAN, which stands for polyacrylonitrile.
Okay.
These fibers are then heated very carefully to get rid of all the non-carbon parts.
So you're basically baking out all the impurities until you're left with pure carbon.
That's a good way to think about it. And then the surface of the carbon fibers is treated to make sure it bonds well with other materials when you're making composites.
Composites.
Yeah, that's because carbon fiber is often combined with resins or other materials to create structures that are even stronger and more versatile.
Okay, so it's not just about the carbon itself, it's also how you process and prepare it to create those unique properties.
Exactly.
Well, we've covered a lot of ground. We've talked about the fundamentals of carbon fiber, its incredible properties, and why it's used in such demanding applications.
It's been quite a journey.
It really has. But I'm curious to hear about some of the more unexpected places where carbon fiber shows up.
Oh.
I mean, we've touched on aerospace and bicycles, but I'm sure there's more to the story.
Oh, you'd be surprised how many different applications there are for carbon fiber.
I bet.
We'll dive into some of those in just a moment. You know, one area where carbon fiber is really making a difference is in wind turbine blades.
Huh. Interesting.
Yeah, you know, as we're all looking for cleaner sources of energy, we need these blades to be longer.
To catch more wind.
Exactly. But the longer they get, the stronger and lighter they need to be, too.
I can see where this is going.
Carbon fiber to the rescue. It's the incredible strength-to-weight ratio again.
Right.
We can build these longer, more slender blades that can generate way more power.
Without putting too much stress on the structure.
Exactly. So, yeah, I guess you could say carbon fiber is helping to make wind energy more viable.
It really is amazing how this one material is popping up in so many areas that are important for the future.
It is. And it's not just big things like wind turbines either.
How else?
Well, it's finding its way into things we use every day, too. You know, like clothes.
Wait, carbon fiber clothes?
Yeah. Heated clothing. They're weaving flexible heating elements made from carbon fiber right into the fabric.
So you could have a jacket that, like, warms you up at the touch of a button?
Pretty much. It's perfect for athletes who train in cold weather.
Or, you know, anyone who just hates being cold.
Exactly. But that's just one example, you know. As the technology keeps improving and the cost comes down,
Yeah.
I think we'll see carbon fiber become even more common in our everyday lives.
I can definitely see that happening. Our clothes, our cars, you name it.
All lighter, stronger, and more efficient thanks to carbon fiber.
Amazing.
Yeah.
But, we talked about the cost of production earlier.
Right.
It's a big hurdle, right?
Yeah.
What are researchers doing to try and bring that down?
There are lots of smart people working on it. One thing they're looking at is using alternative materials.
Like what?
Well, right now, most carbon fiber comes from PAN.
Pan?
It stands for polyalkylonitrile, but basically it comes from petroleum.
Oh, okay.
But scientists are looking at other sources like lignin.
Lignin.
It's a byproduct of the paper industry, actually.
Interesting.
And they're even looking into some plant fibers.
So we could potentially make carbon fiber from renewable resources.
That's the goal. And if they can pull it off, it would be huge.
Yeah, it would make production more sustainable and probably help bring the cost down, too.
Exactly, making it more accessible for everyone.
That would be a real game changer. What about the manufacturing process itself? Any exciting developments there?
Definitely. 3D printing with carbon fiber is a really hot area right now.
Whoa, so you could print carbon fiber structures.
That's the idea. Layer by layer, no need for the old molding or weaving techniques.
That's wild.
It's still early days, but it could totally revolutionize how we work with carbon fiber.
Making it faster, more flexible, and hopefully cheaper, too.
You got it. But, with all this talk about making more carbon fiber, we can't forget about the end of its life cycle.
Recycling.
Exactly. We have to figure out how to close the loop and make the whole process truly sustainable.
I agree. What are some of the ways people are looking at recycling carbon fiber?
There's a technique called pyrolysis, which is pretty promising.
Okay.
Basically, you heat up the carbon fiber composite in a special oxygen-free environment to break it down.
So you're kind of reversing the manufacturing process.
In a way, yeah. You want to reclaim those valuable carbon fibers so they can be used again.
Smart.
It's tricky, though. We need to refine the process so that the recovered fibers are still strong and high quality.
Makes sense. Are there any other methods?
Yeah, mechanical recycling is another one. That's where you break the composite down into smaller pieces.
And what do you do with those?
You can use them as filler in other products.
So even if you can't always get those perfect fibers back, you can still find ways to reuse the material.
Absolutely. Keep it out of landfills. It's all about creating a circular economy for carbon fiber.
I like it. Recycle and reuse, minimize waste, and lessen the environmental impact.
That's the goal.
Right.
As demand grows, we have to be responsible about how we use this amazing material.
Well said. It's encouraging to hear about all the work being done to make the whole life cycle more sustainable.
It's something we all need to be thinking about. Material science isn't just about amazing materials.
It's also about thinking about the planet.
Exactly.
This deep dive into the world of carbon fiber has been incredible.
It has been fascinating, hasn't it?
I mean, from its structure and properties to its crazy applications and what the future holds.
It's a pretty wild ride.
It really is. But before we wrap up, I'm curious, is there one key takeaway you want to leave our listeners with?
For me, it's that carbon fiber. It's more than just a material.
I know what you mean.
It really speaks to human ingenuity, our drive to push those limits to see what's possible.
It really does. And it's exciting to think we might be on the cusp of a real carbon fiber revolution.
I think so, too.
Where this thing that was once exotic, only used in these high-tech applications,
Right.
becomes a normal part of everyday life.
Yeah, exactly. And, as we keep innovating, as we keep pushing those boundaries of material science,
Yeah.
who knows what else we'll discover?
Well said. On that note, I think this deep dive has been absolutely incredible.
Oh, it's been a pleasure.
We've learned so much about carbon fiber, from its structure and properties to its mind-blowing applications and what the future might hold.
It's a pretty amazing material, I have to say.
It really is. And for our listeners who want to go even deeper into this world of materials,
I'd say definitely do that.
be sure to check out the Material Science blog. It's in the podcast details.
Yeah, it's a great resource.
It's packed with insights and info on everything from those everyday materials we kind of take for granted,
You don't even think about them.
right, to those cutting-edge materials that are, shaping the future.
Pushing the boundaries.
Exactly.
Yeah.
And like we said, we've only just scratched the surface today.
Oh, yeah. Just a taste.
Yeah. There's so much more out there to learn about material science.
A whole universe.
It really is. So until next time, keep exploring, keep questioning, and keep your minds open to the amazing possibilities of the material world.